Hello from Heathcote Electronics. This video will describe what all the terminals on the IRDOT-1 infrared detector do and how to connect various LEDs to these terminals. It may be more easily understood if you watch the video about infrared detection first, which has a link from the comment section. The terminals are numbered on the IRDOT-1 board. You can see them just to the right of the terminals. These are the instructions supplied with the IRDOT-1. They describe how all the output terminals work. Terminals 1 and 6 connect the IRDOT-1 to its power supply. If using 12 volts DC, the positive connects to terminal 1 and the negative to terminal 6. The IRDOT-1 is supplied with an LED. The long leg of this connects to terminal 5. And the short leg of the LED shares terminal 6 with the negative power supply. This LED lights when the IRDOT-1 detects a train. So the LED lights when the IRDOT-1 is detecting. The remaining terminals, terminal 3 gives out a fixed 11 volts and terminal 4 isn't used. Terminal 2 is the terminal that connects to accessories such as station stops, shuttles, boards controlling signals, etc. So that gives a special electronic signal to operate those boards. To explain a little bit more about terminal 2, I've got the terminals here. Here's 6, here's 1 and here's 2, and the positive power goes in there and the negative power goes in there. Well, what happens with 2 is actually technically called a open collector transistor, but you don't really need to know much about that. Right, so internally the emitter of the transistor goes to 6 and the collector goes to 2. But what it really means is that when the IRDOT-1 is detecting, 2 is connected to 6. It's as if you had a switch connecting 2 to 6. When the IRDOT-1 is not detecting, there is an open circuit, as if this switch between the two has been opened. So terminal 2 can be used, as we've said before, to connect to other circuit boards we make, so that when a train is detected by the IRDOT-1 in a certain place, the wire will run to 2, and that will say to the other board the train's arrived. It's also got some other uses. Suppose you wanted to switch a relay on and off. So you would connect this to the relay coil, and then the other end of the relay coil, if you were using 12 volts DC, you could connect it to terminal 1. If you weren't using 12 volts DC, as we said before, there's 11 volts and it is 11 volts DC on terminal 3, so you could connect that wire to there. So now what would happen if there's no train being detected, then there's no connection from 6 to 2, so the current from terminal 1, the 12 volts, can't flow because there's no connection. As soon as you start detecting something, this switches to 0 from the connection from 6 to 2, and so a current flows through the relay coil, and that would switch the relay on and switch the relay contacts over. All the LEDs we supply with our circuit boards are the type that need a resistor. If they don't have a resistor, then they will just be destroyed by the current. So terminal 5 on the circuit board there is a resistor to limit the current. Suppose you want to indicate on your hidden sidings on the control panel when a track is empty with an LED as well as when it's occupied. Then you can use a green and a red LED. So the green lights when the IRDOT-1 is not detecting and the red lights when it is detecting. Well, the red is just into the terminals 5 and 6 as normal. The green LED has a resistor that goes into terminal 2. Well, when it's not detecting, terminal 2 is just an open circuit, so the fact that it goes into terminal 2 doesn't make any odds. So the resistor takes the 11 volts down through the green LED which lights it. When the IRDOT-1 is detecting, then terminal 2 connects to terminal 6, so it's at 0 volts. So this end of the LED is at 0 volts, this end is at 0 volts, so it can't light. So it only lights when it is not detecting. Rather than having a separate red and green LED, you might want an LED which changes colour. If we have the red LED and the green LED, imagining both of these encapsulated in the same piece of epoxy, and inside these two legs are joined together, then what you've got is the three-legged bicolour LED. This is a three-legged bicolour LED. The centre leg is the common. The top leg, when you make that positive, makes LED green. The bottom leg, making that positive, makes LED red. Now we need to solder 3 wires to the 3 legs of the bicolour LED. This is how I solder wires to LEDs. I put some of this, which is called heat shrink, over the joint. It's a special type of rubber that when you heat it up it shrinks down in size. The reason I do that is to stop the legs touching each other and causing a short. So if you get some black wire for the centre, which is a common, strip a bit off, twist it round, and then what I do is I wrap it around the leg. The reason I do this is because it doesn't move when I make the solder joint. If it was to move as you made the joint, as the joint cooled, then you tend to get a very bad joint that's very brittle, called a dry joint. Right, now I can put a bit of solder . Need to trim this little bit of wire off, cover it up with the heat shrink, now the best thing to use is a hot air gun to shrink it down. If you haven't got a hot air gun, then the side of the soldering iron works reasonably well. Now I'll just put the other 2 wires on and then we'll see about connecting it to the IRDOT-1. Here's the bicolour LED with the 3 wires soldered to it and covered with the heat shrink so they can't short each other out. Now it's just a case of connecting these up to the IRDOT-1 board, and we also need to connect up the resistor between terminals 2 and 3. Here we have the green wire into terminal 2. That goes to the very shortest leg on the bicolor LED. The resistor goes between terminal 2 and terminal 3. So terminal 2 is shared by the green wire on one end of the resistor. The red wire, which is the middle length leg on the bicolor LED, goes to terminal 5, which was originally where the long leg of the red LED goes, so that makes sense. And the common, the centre leg of the bicolor LED goes to terminal 6. We'll just switch it on now and see what happens. So we're detecting the top of the table. Now we're not. We detected absolutely nothing. There's no train there, so it's showing green as it should do. Right, the train comes along and we change to red. Train goes away, back to green. I hope you found this video interesting and informative. If so, then keep an eye out on our channel, as we plan to make quite a few more.